for the BST activity, okay, there are A and B activities here, in which for letter A, we have to create the binary tree class and implement its operations. So the BT node itself class is needed for the binary tree class because we need to create node for the binary tree. Okay, and of course in each node we have the important information, and in this case you are required to create an integer type of info for each of the element, and each of the node must have the references for the left and right link, and of course the type or BT node itself. All right, so and we have also default constructors and constructor with parameters. Okay, only one default constructor, of course. Default constructor and constructor with parameters. So there are two constructors for BT node class. And this must be the parent class of BT class. I know, instead, this is not a parent class, but a composition. Okay, because this will be um, used in the BT class. All right. So in the BT class, we need to use the BT node. Okay, because here we are going to use the BT node class in creating the node elements. Okay, and here we need to have one variable, the reference variable of type BT node, and the methods with constructors, the default, and the constructor with parameters, and is empty method that will be used to check if the binary tree is empty. The three traversals, okay, the in-order traversal, post-order, and the pre-order traversals. Remember the demonstration that we had last meeting, okay, showing you the code of some of the operations, including the traversals. Okay, but the traversals are the recursive methods for in-order, pre-order, and post-order. And the height method to return the height of the binary tree. And the node count to return the count of nodes in a binary tree. And this BT class will be used as a parent class of the binary search tree. Okay, this can be found at the letter B. In the letter B, you're going to create a binary search tree class derived from the binary tree class and implement its operations. So what are the own operations of binary search tree? So these are, of course, we have to overload the method SMT, okay, to check if the binary search tree is empty. The search, okay, the search operation, this will be used to verify if the search item is found at the binary search tree. Okay, insert, okay, that is to insert a new element. Delete is to delete an item from the binary search tree. Okay, same as we have here the height, just to um, override the method from the binary tree, and the leaves count to return the number of nodes or number of leaf nodes in the binary search tree. Okay, in the binary tree, all the nodes, and in here in the binary search tree, just the leaves, okay, to return. All right, the rubrics for grading is the same rubrics that um, the same rubrics that were used in the laboratory exercises that contains the criteria for solution, program design, code readability, delivery, but no Q&A since this is only intended for face-to-face checking. Okay? But for this, um, the delivery, okay? Delivery in terms of not the time, but of delivering or explaining your code because um, another that would be in another activity. Okay, so there are two components in the class record that will be affected in this activity: the problem component or programming problem components and the oral participation component. Okay, the oral participation component will be look like this. You're going to, but don't worry, I will be creating the details in the LMS. Okay, um, you're going to explain your code, and same with the previous oral participation, you are going to record your explanation to be uploaded in YouTube. Okay, and this will be done by pair. Sige, you are free to choose your partner. Okay, only two members per group. Okay, then I will be showing you the demonstration on uh, running the binary search tree. Okay, so let me exit this one for a while. Okay, let me run this one. Okay, it must be user defined or menu driven, and all of the elements must be user defined. Okay, just like this, we have 1 to 9 options, and in which 9 will be the exit to exit the program or to end the program. And one is insert, like insert a new element to the BST. 2 is delete. 3 is search. 4 is print. And in printing, you have the options to choose the different traversal. Okay, count parent, count leaf, count nodes height. Okay, so for example, let me insert an item. So for example, an item that is 10. Okay, another one is another insert which is 5. So since 5 is less than 10, it must be at the left of 10. Another one, insert 15. Since 15 is greater than 10, it must be at the right of 10. Okay? Then when you print, okay, for example, I'm going to print the in order form, in order traversal. So we have 5, 10, 15. Remember, the in order traversal must be traverse the binary search tree in left root right. That is 5, 10, and 15. Okay? And for example, we need to search the 15. Okay, so 15 exists. It will just return whether exists or not. Okay, the search item existed in the binary search tree or not. Then, for example, I'm going to count the parent nodes 5. So there's only one parent node here, the 10. And for For example, count the leaf nodes. 6. So there are 2 leaves. Since 5 and 15 are the leaf nodes of this binary search tree. Okay, how will you know that the node is a leaf node? If both of the left link and right link are null. Okay, and the height. Wait. Let me have the count nodes first before the height. So count nodes. So there are 3 nodes in this binary search tree, and the height. So we have 1. Okay, so there is only one path from the root to the subtrees. Now, for example, we need to insert, diba, 5, 10, 15. For example, we are going to insert 12. So 12 must be at the left of 15 since it's less than 15. And we need to insert 20. Now, let's try to print 4. And we're going to print in an in order format. So 5, 10, 12, 15, 20. Okay. And if we're going to print in a pre-order format, okay, in a pre-order format, remember, if you put the binary search tree in your mind, the left subtree of 10 is 5, the root is 10. At the right of 10, we have 12, 15, and 20. When you traverse this one using the pre-order traversal, 10, 5, 12, 15, 12, and 20, since the pre-order traversal will start at the root, then go to left and go to right. Okay, so print 4, and we're going to print in the pre-order traversal. So we have 10, 5, 15, 12, and 20. That's correct. Then if we're going to print it in the post-order traversal, okay, what should be the arrangement of the items? In the post-order, it's left, right, root. Okay, so it must be printed in 5, since 5 is the left subtree of the binary search tree. Then at the right, we have 12, 20, 15, and 10. So it must be printed 5, 12, 20, 15, and 10. And print in the post-order traversal. So 5, 12, 20, 15, and 10. That's correct. Okay, and let's go for the height. So the height is 2. Okay, because in the longer path, we have at the right. So at the right of 10, there is 15, and 15 has another subtrees. We have the left and right. Okay, so there are 2 paths on the longer path of this binary search tree. Okay, so exit from the program. All right.